Hey guys, welcome back to our channel. Today we are going to solve the problem known as longest consecutive sequence. Okay, so we are given an array which is unsorted and we have to return the length of the longest consecutive element sequence, right? So basically, for example, we have this array, right? 100, 4, 200, 1, 3, 2, right? So the longest sequence is like we have 1, we have 2, we have 3, we have 4, right? So 1, 2, 3, 4. That is consecutive sequence we have. That sequence is of length 4, right? And after that, this 100, we don't have 101. We have 200, but not have 201. So the longest possible sequence is 1, 2, 3, 4, and the length is 4, right? Similarly, in this also, the longest possible sequence is 9. Okay. So before we start coding up, let's think of the possible solutions we can do to solve this problem. So now we have this array 100, 4, 200, 3, 1, 2, right? And we have to find the longest possible sequence. Okay. So before we start, okay, let's think what is the naive solution or the brute force one for it. If we have to find the longest, let's say I am starting from 100, right? So if I need 100, the next element should be 101, right? And if 101 is there, then I will look for 102 and so on, right? So I started from my first element and in the remaining I will search for 101, correct? If I found, then I will look for 102 and so on. Yes, so here 101 doesn't exist. Now let's move to the next element, right? That is 4. So 4 has to be in consecutive sequence. That means I need 5, right? Let's look for 5 in this whole array. No, 5 is not there. That means this is also not my longest sequence, right? Now let's go to the next element, that is 200. So for 200 I need 201, right? Is 201 in this array? No. That means till 200 on we are not getting any sequence. So our current sequence is of length 1, because see, if we take 100, and that means it is of length 1, right? So the max is still 1. Now let's go to the 3. So for 3 to be there in the sequence, we have to search for 4, right? So 4 is there. That means our counter for the current sequence is 2, right? Now we got 4. Now let's look for 5. Is 5 there? No. So that means 3 and 4 is my sequence that I got till now, right? And I will update my max as the current length will become 2. Now let's go to the 1, right? So for 1 to be in my sequence, I need to look for 2, right? Let's look for 2. Is 2 is there in this array? Yes, it is there, right? So my current counter will also be 2. Now as I have got 1 and 2 both, right? And max is still the 2. Now after 2, what I need to search is 3, right? Is 3 there in the array? Yes, 3 is there in the array. So my current counter will become 3 and max will also become 3, right? Now after 3, for it to be consecutive, I need to look for 4. Is 4 in this array? Yes. So my current count will become 4 and I will update the max also as 4 because the count is greater than max. After 4, let's look for 5. Is 5 in this array? No. That means my current sequence is of length 4 and I have updated it, right? Now after 1, let me go to the next element. That is 2, right? So after 2, I will update my count to 1, that is of length 1. After 2, what I need to do? I need to look for 3. Is 3 in this array? Yes. I will update my count to 2. After 3, I need to look for 4. Is 4 in this array? Yes, I will update my count to 3 now. Now after 4, I need to look for 5. Is 5 in this array? No. So my current count is 3 and the max is 4. So my overall max will remain 4 and this is my longest sequence of length 4. Right. So this is the brute force solution. What we have done is we have looped through this array that is from 0 till the n, where n assuming the length of the array, right? And after that, for each element, right, for each a of I am looking for a of I plus 1, right? A of I plus 1, right? Correct. And basically, I am running a while loop here. If I am having a of I plus 1 in my array, then I'm increasing my count plus plus and updating the max also, right? So this is what I'm doing as of now, running a for loop and inside it one more for loop if I found the sequence. So considering time complexity, as I'm running two for loops or two loops in the end, so it will be of n square, right? And as I'm not using any extra space, so space will be of 1, right? So this is the most, naive solution. Now let's think of the next solution. So far we have looked the brute force approach, right? So in the brute force one, what we have done is we are checking each element, and for the each element in the array, we start looking for the plus one, plus one, plus one, basically the next elements, right? And we are just counting the length of the array, not the length, basically not the length of the array, basically the count of the, the consecutive we are getting, and according to it that we are updating the max, right? So brute force one is like checking each element, checking the next, and so on, right? So it took us n square, right? Now we can make it better, right? See, we have to look for the consecutive ones, right? So the best or the better way we can do is make the consecutive ones together, basically make them how much close we can, right? So to do that, let's sort this array, right? And to make it understand better, let's say we have one more one here. And see, I am adding one more one here, to make you realize that we can have duplicate elements also in the array, right? So 1, 1, 2, 3, 4, and 100 and 200. Okay, so now we have this our sorted array, correct? So what we have to do is see the most obvious thing is till now we know that okay, if we maintain the current count we need one variable that is c, and to maintain the max we need one variable that is m. Basically max will be the longest length we got till now and the current count will be this count will be covers the current length. Okay, so the difference or the thought process we can have here is, or we got it from sorting is, instead of checking the next element, can't we look if we got a minus one in the previous time? Okay, so what I mean by this is, let me maintain the the last element we got. Okay, let's track of this also. I will dry run this, then you will understand the importance of this last element. Okay, so before we start, let's initialize all this like max and count as 0, 0, and I will make it as a minimum. Okay, let's say this minus infinity. Okay, now let's start. Okay, here what we are trying to do is we are checking each element And while checking, we have to take two decisions. Okay, what are the two decisions? Either is it part of the current sequence or we are starting a new sequence. Okay, these two decisions we have to take, because see, any element we are having, either it can make a new sequence, basically it can be the starting point, or it can be a part of sequence, correct? So to check these two things, what we can do is, we have one, we can subtract -1 and check if it is equal to LE, right? If it is equal to LE, that means we have one less already existing, right? That means it is a part of the current sequence. And if it is not LE, that means this one can start a new sequence, right? So let's try run this. We have 1. So 1 minus 1 is 0, correct? And if 0 is LE, no, that means this one can be the new sequence and it can start a new sequence. So my current count will become 1 and my max will become 1, and the last element, or basically that we have traversed, is 1, correct? Now let's go to the next element. It is again 1. So if we get the, if current element is same as the LE, that means it is a duplicate one and we can simply ignore. Now move to the next element, that is 2. Okay, so 2 minus 1 is equal to 1, right? That means is equal to LE. That means this 2 can be my part of the current sequence, right? If it is a part of my current sequence, I can increase my counter. As counter is becoming greater, that means I can update the max and my LE can be 2, right? Now let's go to the next element, 3. So 3 minus 1 is equal to 2, right? That means is equal to my LE, and that means it can be my part of the current sequence. So I can increase my counter by 1, and as the counter increase, I can make my max also 3, right? And I can update my LE as 3. Now let's go to the next element, 4. That means 4 minus 1, right? If 4 minus 1, 3 is my last element, right? That means this 4 again can be a part of the sequence. I can update the counter as 4 because my sequence is still continued, and I can update my max also as 4, right? Now LE can also be 4. Now let's move to the next element. Okay, now this is the important one. Now let's see, 100 minus 1 equal to 99, right? Is 99 my LE? No, my LE is 4, right? And my, if, and I, after getting 100, we are getting, subtracting 1, we are getting 99. That means this 100 can make a new sequence, right? Because the previous element doesn't exist. That means I can start a new sequence with count as 1 and my LE as 100, right? And still, as the max is 4, it will remain 4 because max is the overall longest sequence, because till now we have got a sequence of 4, right? Now let's move to the next element. It is 200, right? So 200 minus 1, or not 1, yeah, 1 only, we get 199. So do 199 is my last element? No, that means this 200 has to be my new sequence. That means I can again initialize my count as 1 as we are starting a new sequence, and the max can remain 4 and my LE can be 200, right? So we have traversed the array and we are got have max sequence, that is 4. So, so basically what we have done, or what's the difference here? We are tracking the previous element, checking the -1 or the previous element. So instead of searching for the next one, we are looking for the previous, right? And why the previous we are easily able to track in this, last element, because we have sorted the array. And after sorting, we know the previous can be the consecutive one, and we can just simply store it, and we don't need to linearly search that previous. Correct. So we have saved that of and linear search time by sorting the array, right? So that is the difference between brute and optimal or the better approach. So here we are looping through this n time of n, but we sorted it also. So the overall time complexity will become n logarithmic of n, right? And as we are using constant, you know, space, not extra space, only, we are using three variables, so the space complexity would be O of 1, right? So this is better than our brute force, because in brute force we did with n square, now we have reduced it to n log n. Now let's see, can we make it, of n, or maybe better? Now we have looked the better approach, right? Now let's see another approach. Okay, and this is the most optimal one, and under certain conditions. Okay, this is not will be the always optimal one, but let's see how we can proceed in this approach. So in this approach, what we can do is, till now, we are taking, see, let's start from the beginning, so that you can get the intuition, okay, how we are thinking of this approach. We started the brute force, right? In brute force, the problem was the linear search, because in linear search, we are consuming O of n. To avoid that, we thought, let's sort this array, right? If we sort that array, then the, traversing is become easy, and we can maintain the last element, right? And after sorting, still the, the time we are taking is n log n, right? So we have to, what now the optimal can be, we don't need to have to do the linear search, and also we don't want to do the sorting, right? So we have to do the searching in O of 1 and without the sorting part, right? And if we have to search in O of 1 and without sorting, we know we have a data structure, right? That is set. Okay, we can use set here, and assuming in set the search time is of 1, so we can easily do that. Okay, so what we have to do is put all our elements in the set. Okay, now we put 100, right? After that 4, 200, right? Then 3, then 1, then 2, and as again 1 is coming, but set has only unique ones, so that's it, right? Now we have elements in our set. That means the search time is of 1. Under these conditions, we are proceeding with this approach. Okay, now let's start from the first element. First one is 100, right? So what we need to do is again the same approach. Is 100 is there, so what we can do is 99 exists in this array, or in this set, sorry? No, that means we can look for this. That means this 100 can be my part of sequence, or we are starting a new sequence, right? And for that, let's maintain two variables, count and max, right? So now this 99 doesn't exist, that means this is my new sequence. Now let's look for 101, right? If 101 exists or not. And to search that, we will search in the set, and that is O of 1 we are assuming, but 101 doesn't exist. That means till 100 we have count 1 and sequence max as 1. Right. Now go to the 4. Okay. We have 4. So 3 does exist in this set. Yes, 3 exists. That means this is not my new sequence, and we don't need to search now, because we can search when 3 will come, right? See, if we are having 4 and 3 already exist, it doesn't make sense to start from 4, right? We'll start from 3 only, right? For our sequence and make it longer so we can skip. Now, let's go to 200. So, in 200, let's look for 199. Is 199 there? No, that means I can start a new sequence. So I can make my count as 1 and max is again 1. Let's look for 201, maybe the next element. Now 201 do exist? No, that means only length 1 is possible. Now let's go to the 3. So for 3, let's look for is 2 exist? If 2 exists, that means we don't need to start from 3. Is 2 exist? Yes, it exists. That means I can ignore this. When 2 will come, I can start my sequence or start counting basically. Now let's go to the 1. Right. So 0 exists. We will check. No. Basically, we will check if 1 minus 1, 0 exists. Right. Basically, we are checking for previous element every time. No. That means I can start a new sequence with count and max is 1. Now with 1, right, I can look for 2, basically the next element to start my sequence. Is 2 exist? Yes, it exists. That means till now my length will become 2 and my max will become 2, right? Now look for the next element, that is 3. Basically we are incrementing 1 by 1 because we want to look the consecutive. Is 3 exist? Yes, it does. So my count will become 3 and my max will become 3, right? Now let's look for the 4. If 4 exists, yes it does. That means my count will become 4 and my max will become 4, right? Now let's increase one more, that is 5. Is 5 exist? No, that means we are done, right? Till now we have 4. We can move to the next element, that is 2. Now in 2, we need to search for the 1 less. Is 2 minus 1 equals to 1 exist? Yes, it does. That means this is not part of my sequence, right? So the max element we have got is 4 and we can return the length. Now, important is let's see the time complexity for this. Okay, so time complexity for this is, O of 2n. Okay, this is O of 2n, right? And we are using an extra space, so that will be O of n. Okay, but now you people will be thinking, see, we started the one for loop, and after that we are, checking by increasing 1 by 1. That is another loop. So it should be n square, right? But try to understand, okay, in this whole array, right, what we are doing? We are traversing this array 1, 2, 3, 4, 5, 6. That is length 6, right? We are traversing 6 times. After that, 400 we ignored, for 200 we ignored, for 3 we didn't run, for 2 we didn't run, only for 1 we ran the array, right? That is 1, 2, 3, 4. That is 4 times, right? And 400 also we tried to run. I'm sorry, I just said we didn't run, but 400 also, as it is a part of new sequence, and 200 also we ran one time more, right? So instead of running this iteration for every element, we are running for specific elements. And if we see, this is also 6, right? And this is also 6. So instead of n square, if we see, even after having two nested loops, we are running the very minimal time. That is only 6 plus 6. That is, if 6 is the value of my n, that is around 2n, right? So this is the optimal or the most optimal solution under the condition only that my search time in this set is of 1. Okay, if the search time is not O of 1, then my last approach is the optimal one where I sorted the array and the time complexity was of and log n, right? So now we have understood all the approaches. We started from the brute force, then did a better approach, now the optimal one, and we know how we, the intuition also, how we, go till the from brute force to the optimal one. Now let's go back to our code editor and code this solution. Now we are back to our code editor. So let's see what we are given. We are given an array nums and we have to return the number, a number that is the longest sequence possible, right? So what we have to do, we will use set as I don't want to sort, as I don't want to waste time in sorting and in linear search. Okay, so so I don't want to waste my time in sorting and in linear search. I want to save my time, so I will use a set, right? So let me declare a set, and in JavaScript we can just simply do set, and to insert the elements in set, I can just simply use a spread operator and done, right? So this till now it's done. Now what we can do is we can loop through this, right? So to loop through that, what we can do is, you know, I can simply do hash set dot for each, right? My element, and for that I can always do before we start, I can declare my variables, my count as 0 and my max. Okay, max is also a 0. So what I need to do is, if you know if my element exists, okay, instead of this let me do the has, is my element in this hash set, right? Not the element, basically the -1. If this is there, that means I don't have to do anything. So basically if it is not there, what I need to do is I need to start looping, that is number, or we can say element to be find, right? And it should be element plus 1. We are looking for the next elements now, right? So till our hash set has our elements which we need to find to make it consecutive sequence. That means I can increase my counter, right, as 1, or before this, as we have found the new element, I can make my count as 1 and max also as, you know, I can simply use the max and the count. Okay, I can update my max, and if I am able to search the next element, okay, that means I can increase my counter and I can change my max as mat.max, or take this max here, right? And as I'm looping, so what I can do is I need to, after I got the +1 element, right? After that I need to search for the next one, right? So what I will do is I will increase the element to be found by 1. Okay, so this I will do. Now what we have done is we are looping through this, and if one less than the current element doesn't exist, that means I can start a new sequence. So I can initialize my count as 1 and change the max, and then after I know I am in a new sequence, I will start looking for the next elements. To look for the next elements, I am increasing my find by 1 and updating my count also. Okay, so this all we have to do is, and in the end I can just simply return the max. Now let's run this and see. So this is accepted. Now let me submit this and see if it runs or fails. So it is running successfully now, right? So basically here the important part is we moved from brute force to optimal or the better because of this. we don't want to sort the array because it will increase my time, and I don't want to linearly search in my array, right? So I'm using a hash set to avoid my sorting and to assume it will search in O of 1. Okay, so I hope you guys have understood. So if you guys have any doubts, please write down in the comment section. I will help you out. And if you have understood, just write understood in the comments and I will read all of your comments. So that's it for this video now. We'll see you in the next one. Till then, take care.